Hello everyone, in this video I want to talk about something called biodiversity and how you can work out the level of biodiversity in an environment using what's called the Simpsons Index. Now this is something that you really touch upon at Key Stage 4 but develop further at Key Stage 5 at A level, and that's who this video therefore is aimed at. So let's first of all think about what we mean by biodiversity. It is actually a very general term used to describe the variety of organisms in the living world. That's all biodiversity is. It represents all the living organisms that we have in the living world. Now, there are three particular terms that come up in this topic. One is genetic diversity, which is the variety of genes in individuals of a species. One is ecosystem diversity, which is the range of different habitats in a particular area. But the one that I'm interested in as part of this biodiversity video is species diversity. Because the species diversity is a value that takes into account the number of different species and the number of individuals of each species in a community. So not just how many of an individual species you have, but how many total different species you have in that environment. So let's, for example, let's draw just a sample of a field, and we're going to need a few flowers for this. So very simple here, we've just got a few flowers, not the best diagram. We're going to have a red one here, red one here. Let's say we've got a blue flower here, and for the sake of argument, let's just say we have a yellow flower over here. Let's say you're given this particular ecosystem, this lawn, for example, and you're asked to work out the biodiversity of it. Then we're going to need to use something called the Simpsons Index. Now the Simpsons Index is a formula that looks a bit like this. So I'll talk you through what each of these things mean. So D represents our value or our level of biodiversity. Big N, so this value here, this big N, represents the total number of organisms of all the species. So the total number of organisms of all species. The smaller of the n's here represents something different. This represents the total number of just one species. And the symbol which you might recognise, this one here, means sum of. So I added together. So we're going to work out the total number of each species, add them all up, put them into this formula using the total number of organisms of all species, and that should give us a value for what's called the Species Diversity Index. So D, the value of D here, is what's called a Species Diversity Index. And we use that as a measure of biodiversity. So let's work that through for this particular example I've drawn. So we'll just reduce the screen a little. And let's take each species in turn. So we've got red, we've got blue, and we've got yellow. Now you'll notice we have 2 of the red, we have 1 of the blue, and 1 of the yellow. And these numbers here are going to be our little n's in the formula. They're going to represent the total number of each species. And big N is the total number of organisms of all. So in total we have 4 plants. We have 2 red, 1 blue, 1 yellow. So the total number of organisms of all species is 4. So D, our species diversity index, is equal to 4 times by 4 minus 1 over, and the sum of, so we need to add up all of the individual n times n minus 1s, and each n is each of the separate organisms. So let's take the red flower. N is 2 times n minus 1, which is times 1, is 2. So for the red flower that would be 2. For the blue flower, n is 1, and we're timesing that by n minus 1, which is 0. So 1 times 0 comes out as 0. So that's 0. And finally, we need to do little n for the yellow species. So again, like the blue, we have 1 times by 1 minus 0, which is a total of 0. So what we have here are 3 values, 2, 0 and 0. They are calculations for the total number that we found of each individual species, and then we're going to do the sum of, which is them all added up. So this top formula, 4 times by 4 minus 1, that comes out as 12. The bottom number comes out to 2. So we get a value of D as 6. It's that simple. So we have a species diversity index of 6. Now on its own, it's very difficult to tell a great deal from it. But what you would ultimately do, and what an exam question would do, is give you another environment and perhaps ask you to compare the diversity of both. So what I wanted to do is to show you the Simpsons Index, the formula, how it works and how you work it out, the species diversity index, and explain what biodiversity is. But let's just go one step further. Let's just imagine that you're given 2 environments, X and Y, and you're told that habitat X has a value for D of 5.4, let's just say, and yet you're told habitat Y has a value for D 1.8. And the exam question may be, what does that mean? So clearly, the higher the value for D, the greater the species diversity, also the greater the biodiversity essentially. And the value for D can range from 1 to infinity. So clearly, in summary, the higher the value of D, what that means is the more stable the ecosystem. So let's explain what we mean by that. In a stable ecosystem, you would have such diversity where plants and animals, a whole great range of plants and animals would be able to survive and thrive. And if that is the case, if you could have lots of different plants and animals surviving and have such a diverse ecosystem, if you like, then that would imply that we've reached almost a stable point in that environment. Perhaps where we're not getting mass predation or mass competition to a point that is ultimately affecting our species diversity. So that's what D tells you, not just how diverse something, or not just the level of diversity we have, but it can be used to represent the stability of an ecosystem. Now, one exam question you might get is, what kind of things could cause instability and actually reduce species diversity? There's a whole range of answers to that question. Things like, for example, deforestation, or the overuse of chemical pesticides, for example. Both of those result or could result in the destruction of habitats or microhabitats. If you remove forest areas, for example, deforestation, you're removing homes that certain organisms may have, and if you lose those, you would lose that species diversity. Natural disasters could cause instability, for example. Anything that can cause instability that would ultimately reduce species diversity would be a good answer here. But that's a little bit about, in this video, about biodiversity and the Simpsons Index. Okay, hope that helps.